Okay, let's kick things off with what SRE actually is. Think of it as a way to approach IT instead of seeing developers and operations teams as separate groups fighting over problems. SRE brings them together. It's basically about treating your infrastructure like you would a product itself, constantly striving for reliability, efficiency, and automation. At its core, SRE is built on the idea that we should be using data metrics to understand how our systems are performing. We also embrace automation as a key tool, trying to automate as much as possible so people don't have to do repetitive tasks. And finally, error budgets, essentially allowing for controlled failures within acceptable limits, which is a really clever way of balancing risk and delivering value. Okay, let's talk about how SRE fits into the broader landscape of IT operations. Traditionally, teams dealt with issues reactively fixing things after they broke. DevOps tried to change that by bringing development and operations together through automation, aiming for faster releases. But SRE takes this a step further. It's really about treating operations like an engineering discipline, using data to proactively prevent problems and ensure high reliability. Think of it as moving from fixing what breaks to building systems that don't break in the first place. We've also outlined some key differences in our little table here, things like their approach, what they focus on, and the metrics they use. Okay, let's talk about Google's approach to site reliability engineering. At its core, it's all about building reliable systems, and they've really nailed down some key principles. The first thing to understand is that the primary goal isn't to prevent failures because those are inevitable, but rather to minimize their impact when they happen. They call this first rule, don't break things. It means designing systems with resilience in mind, and having strong testing processes. Then it's about embracing failure itself, seeing outages not as disasters but as opportunities to learn. Google actively analyzes what went wrong and uses that knowledge to improve. Automation is absolutely critical. They strive to automate everything from deployments to troubleshooting. And of course, you need to measure your systems effectively with service-level indicators, things like error rates and latency, so you can spot problems before they affect users. Finally, when an incident occur, it's important to conduct blameless postmortems, focusing on the root cause and how to prevent similar issues in the future. Okay, let's talk about the basics of reliability engineering. Basically, it's all about keeping things running smoothly and reliably. We start with service-level objectives. That's what we want our services to do, like a 99.9% uptime guarantee. Then we need to measure how well we're doing with service-level indicators, things like the number of requests handled or any errors that happen. And finally, we have an error budget. It's the amount of downtime or mistakes we're allowed, which helps us balance stability and new features. Okay, let's talk about service-level indicators or SLIs. Think of them as your service's health report card. They are measurable things that tell us how well a system is actually working for our users. A good SLI should be really easy to observe and directly related to what users experience. It also needs to give us clear insights on what we can do to fix any problems, and it must be reliable, meaning the data consistently represents reality. Some common examples are availability, how often is the service up? Latency, how long does it take for things to respond? And error rate, how frequently are requests failing? Basically, SLI help us track performance and ensure our services are meeting expectations. Okay, let's talk about SLO, service level objectives. These are super important for any SRE because they're the bedrock of how we measure success and keep things running smoothly. Basically, an SLO is a target that defines what level of service our users should expect from a particular system or application. It's not just about saying we want to be fast, but actually quantifying how fast. We break it down into 3 parts. The SLI, which are the metrics we use to measure performance, like uptime or response time, the target, which is what we're aiming for, and finally, the threshold, the point where we've missed our goal. It helps us stay focused on delivering value to our users. Okay, let's talk about service level agreements or SLA, which are absolutely vital for any site reliability engineer. Think of them as a promise you make to your users: we will keep the system up and running at this level. And SLA starts with defining what you're aiming for, like 99.9% uptime, or perhaps how quickly a response time should be. We then translate that into our specific commitment, like our API will respond in under 200 milliseconds 99.9% of the time. It's really important to have a system in place to constantly monitor and measure whether you are actually meeting those goals, and importantly, a clear escalation plan if things go wrong. SLA aren't just about numbers, they are about building trust with your users by delivering on what you promise. Okay, let's talk about error budgets. They're a really important tool for SRE teams. Think of it like a safety net. We define how much downtime or service degradation is okay to expect over a certain period. We calculate this based on our system's tolerance and then track all the errors and outages. As we use up that budget, we proactively focus on improvements, automation, and reducing future issues. It's not about accepting failures, but rather managing the risk associated with them. Transparency is key here. Let's start with the basics of what makes a service reliable. As an SRE, you will spend a lot of time thinking about availability and uptime. Availability is really just how much time your service is actually working expressed as a percentage. Uptime is the actual running time, while downtime is where it's not. It's important to focus on both, and calculating availability helps give you a clear picture of performance. A common goal is 3 nines, meaning 99.9% uptime. Don't confuse these terms. High uptime doesn't automatically guarantee a great experience. Okay, let's talk about incident management, a really crucial part of being an SRE. The goal is simple: get the service back up and running as quickly as possible while also understanding why it went down in the first place. We use the 4 R's: run to restore, resolve to fix the root cause, recover by preventing recurrence, and repeat through post-incident reviews. These reviews are super important because they are all about learning from mistakes, not assigning blame, but figuring out what we can do differently next time. Okay, let's talk about how we tackle incidents as an SRE. The first step is always to identify what's going on. That means understanding the impact of the problem and which services are affected. Then we need to categorize the issue, like, is it a problem with our servers, or something specific in the application? Next, prioritization is key. We use a system to quickly decide what needs immediate attention based on how critical it is. Transparency is super important. We keep everyone informed throughout the process. And finally, after the fix is implemented, we do a post-incident review. Basically, we ask what happened and how can we prevent this from happening again. Okay, let's talk about root cause analysis, or RCA, and how it fits into the SRE workflow. Basically, when something goes wrong in our systems, we don't just fix the immediate problem, we need to figure out why it happened in the first place. That's where postmortems come in. We start by clearly defining what actually occurred, when it did, and how much impact it had. Then we gather as much data as possible: logs, metrics, traces, anything that can shed light on the situation. A really helpful technique is using something like the 5 whys method or a fishbone diagram to keep asking why repeatedly until you get to the real root causes. It's not about pointing fingers, it's about learning from our mistakes, documenting everything in a post-mortem, and then creating actionable items to prevent similar issues in the future. A well-written post-mortem is all about systematic understanding and prevention, not blame. Okay, so when we're talking about site reliability engineering, a really important first step is understanding monitoring. It's the foundation for everything else. Basically, monitoring is all about keeping an eye on our systems to see how they're doing. We look at key metrics like service level indicators, which tell us how well a service is performing, things like response time or uptime. Then we set service level objectives, essentially defining what's considered acceptable performance. And finally, error budgets let us know how much leeway we have before things start going wrong. There are different types of monitoring: to synthetic tests to mimic user behavior, APM tools that dig into application performance, and infrastructure monitoring looking at servers and networks. Okay, let's talk about goals and signals. These are essentially the 4 key metrics that every SRE should be tracking. They're like a compass for your system. They tell you what's happening and where to focus your attention. We've got latency, which measures how quickly things respond, traffic, representing the volume of requests, errors, highlighting any failures or problems, and saturation, showing how busy the system is. Understanding these signals consistently helps you stay ahead of issues and keep your systems running smoothly. Let's talk about distributed tracing. It's how we understand what's happening behind the scenes when our applications are talking to each other across multiple services. Imagine a user clicks a button and that action triggers a whole chain of events in different parts of your system. Distributed tracing helps us follow that path, like tracking a detective through a complex maze. OpenTelemetry is a really great framework for doing this. It provides tools to automatically instrument your code so you can collect data about how requests are flowing. And popular backends like Jaeger and Zip can let us store all of that information and visualize the journey of each request, making it much easier to find performance bottlenecks or troubleshoot problems. Okay, let's talk about how SRE handle logs. Log aggregation is a really important part of keeping systems running smoothly. We often use the ELK stack, that's Elasticsearch, Logstash, and Kibana, which is a fantastic open source way to collect, index, and visualize your logs from all over. Logstash gathers the data, Elasticsearch stores it efficiently, and Kibana lets you create dashboards and see what's going on. Low-key is another option, especially if you have lot of logs. It's much lighter weight than ELK. And then there's Splunk, that's a more robust commercial platform often used by larger companies because it can handle massive amounts of data and has a really powerful set of features for analyzing problems. Okay, let's talk about how time series databases fit into the world of SRE. These are tools designed to handle data that changes over time. Think server metrics, application performance, and pretty much anything you want to monitor continuously. Two big players here are Prometheus and InfluxDB. Prometheus is fantastic for collecting metrics, especially those coming from HTTP requests. It's built around a powerful query language called PromQL. InfluxDB, on the other hand, is specifically designed for storing large volumes of timestamp data like logs and events. They both have their strengths, and SRE often use them together to get a really complete picture of what's happening in their systems. Do you have any questions about this? Okay, so let's talk about how SRE keep an eye on things, specifically alerts. We use tools like Prometheus to gather data from our systems. It's constantly sniffing around for metrics like CPU usage or response times. Now, that can be a lot of information. That's where Alert Manager comes in. Think of it as the signal filter. It takes all those alerts and decides which ones are important enough to actually need attention. Then we often integrate with tools like PagerDuty or Opsgenie to make sure the right people get notified quickly and visually too, so everyone can see what's going on. Okay, let's talk about capacity planning, a really important part of being an SRE. It's not just about throwing more hardware at the problem, it's about understanding how your system actually behaves and predicting what it needs to handle in the future. We start by collecting tons of data, things like CPU usage, memory, network speeds, and crucially, how quickly users are getting their requests fulfilled. Then we dig into that data looking for trends. When do we see spikes? Are there predictable patterns based on time of day or week? We use forecasting techniques like time series analysis to predict future demand, and often load testing to simulate what happens when things get really busy. Finally, based on those predictions, we proactively adjust our infrastructure, scaling up servers, optimizing code, or using caching so that we're always ready to handle whatever comes our way. Okay, let's talk about performance testing as part of our SRE toolkit. A huge part of what we do is making sure applications are running smoothly under pressure. We use tools like JMeter, K6, and Gatling to simulate real users hitting our systems, basically tricking them into thinking lots of people are using the app at once. JMeter is a really established tool, great for detailed scripting, while K6 and Gatling offer more modern approaches with easier scripting and focus on mimicking user behavior. It's about finding the right tool for the job. Okay, let's talk about chaos engineering. It's a really important part of being an SRE. Basically, We don't just hope our systems are reliable, we actively test how they react when things go wrong. Think of it as controlled chaos. The core idea is to deliberately introduce failures into your system to understand its resilience. We start by defining what we want to learn from each experiment. Then, we monitor everything closely so we can spot problems quickly. We inject faults in a strategic way, starting small and building up complexity. And most importantly, we analyze what happens and use those learnings to improve our systems. There are tools like Chaos Monkey that help with this, as well as techniques like injecting latency to simulate network issues. It's all about learning from failure and making things more robust. Let's talk about how we actually test our systems for resilience. That's where chaos engineering comes in. We intentionally introduce failures, think network hiccups or service outages, to see how our infrastructure and processes react. There are a few powerful tools that make this possible. Gremlin is a fantastic engine for injecting faults directly into your production environment, allowing you to pinpoint specific weaknesses. Chaos Mesh takes things a step further as a service mesh, letting you experiment with chaos patterns across all your microservices in a controlled way. And Litmus is particularly useful if you're using Kubernetes. It's specifically designed to simulate failures within that cluster so you can practice recovery strategies before anything goes wrong in production. Okay, let's talk about infrastructure as code. It's a huge deal in SRE. Basically, we're treating our infrastructure the same way we treat application code. Instead of manually setting things up through complicated web interfaces, we write code usually using tools like Terraform or Ansible that describes exactly what we want our servers, networks, and databases to look like. Think of it as this is how I want this to be, instead of here's the step-by-step guide on how to build it. A key principle is idempotence. Running the same code multiple times gets us to the exact same result, no surprises. And just like we version control our application code in Git, we should absolutely do the same with our infrastructure configurations. Popular tools include Terraform and Ansible. They're really powerful for managing everything consistently. Okay, let's talk about IC. As an SRE, you need to be able to manage infrastructure consistently and reliably. That's where infrastructure as code comes in. We have a few key tools that SRE use. Terraform is super versatile because it can work with many different cloud providers. CloudFormation is specifically designed for AWS, making it really convenient if you're primarily on the Amazon side. And then there's Pulumi, which lets you use familiar programming languages to define your infrastructure, giving you a lot more flexibility and control. Let's talk about how cloud platforms play a big role for site reliability engineers. As you know, many organizations are now using more than one cloud provider, as Azure and Google Cloud Platform are the top contenders. Each of these has its own strengths. AWS is really mature with a huge community and lots of great tools like CloudWatch and CloudFormation. Azure's got deep integration with Microsoft products, which can be fantastic if you're already using those. And Google Cloud is known for being super innovative in areas like data analytics and machine learning, plus they're leaders when it comes to Kubernetes. Ultimately, the best choice depends on what your application needs and what your team knows well. Let's talk about keeping things running smoothly. High availability and disaster recovery are all about minimizing downtime for our services. Think of high availability as making sure that if one part of a system fails, another immediately steps in to take its place. Redundancy, failovers, and smart load balancing are key here. Disaster recovery is even bigger picture. It's the plan we have when something really bad happens. It starts with regular backups so we can restore everything, and it focuses on defining how quickly we need to be back online RTO and how much data we can afford to lose RPO. Okay, let's talk about load balancing, a key part of any SRE toolkit. We have three main strategies. First up is round robin, which is super straightforward. The load balancer just cycles through your servers in order. Next, we've got least connections, where it sends requests to the server that's currently handling the fewest active connections. Finally, there's IP hash. This uses a client's IP address to consistently route them to the same server, which is useful for maintaining sessions. Okay, let's talk about reverse proxies. They are a really important part of making your systems reliable. Essentially, a reverse proxy sits in front of your servers and handles all the incoming requests, like it's a bodyguard protecting them. This has tons of benefits. It can evenly distribute traffic across multiple servers to prevent any single server from getting overwhelmed, handle the encryption process so your main servers don't have to. Even cache frequently access content for super fast delivery. Two big players here are Nginx and HA Proxy. Nginx is a versatile web server that's great for handling static files, while HA Proxy is specifically built for high availability and really shines when it comes to balancing traffic. Understanding the differences between them will help you build much more robust systems. Let's talk about auto-scaling, a cornerstone of SRE practice. It's all about keeping your services running smoothly even when demand changes. In the cloud, like with AWS, we use scaling groups that automatically add or remove instances based on metrics like CPU usage. Think of it as having an army that grows and shrinks as needed. Kubernetes takes this a step further with horizontal pod auto-scaling HBA. It monitors your pods and scales them up or down to match the load. We'll see a snippet of YAML showing how you'd configure HBA, focusing on defining minimum and maximum replicas and setting a target CPU utilization percentage. Ultimately, auto-scaling leads to better performance for users, reduced costs because you only pay for what you need, and it makes your systems more robust. Okay, let's talk about Kubernetes cluster management for SRE. It's a really important part of the job. We need to ensure our clusters are running smoothly and reliably. That starts with how we actually build them. Using tools like Terraform or Ansible helps us create consistent deployments across all environments. Then it's vital that we have robust monitoring in place, tracking things like CPU usage, memory, disk space, and whether our pods are healthy. We'll set up alerts so we know when something is going wrong before users notice. Scaling is also key, automatically adjusting resources as needed with HBA and cluster autoscalers. And don't forget security, regularly updating Kubernetes and carefully managing access controls. Finally, backing up our data and having a solid recovery plan are absolutely essential. Okay, let's talk about getting your applications running smoothly in Kubernetes. First, we have deployments. These manage the number of copies replicas of your app you want to be up and running. Then, services provide a consistent way to access those apps, regardless of how many instances are active. Finally, ingress is like a traffic director, routing external requests to the right service based on what's being asked for. Think of it as controlling how people get into your application. Let's talk about using Helm charts. They are a super powerful tool for SRE working with Kubernetes. Think of them like pre-packaged apps specifically designed for your cluster. They bundle everything needed to deploy and manage an application, including the configuration files and all its dependencies. It makes upgrades way easier too, because you can roll back to previous versions if something goes wrong. Essentially, Helm gives SRE a really solid way to automate deployments and keep things running smoothly. Okay, let's talk about persistent storage in Kubernetes. It's crucial for any application that needs to remember things between restarts. Basically, we have persistent volumes and persistent volume claims. A persistent volume is like a chunk of storage within the cluster. It's managed by Kubernetes itself. You don't need to worry about setting up the underlying infrastructure. A persistent volume claim is what an app requests, saying, "Hey, I need some storage." Kubernetes then finds a matching volume and ties it to the pod. There are several different types of storage you can use, like services from major cloud providers, network file systems, or even local disks depending on your needs. Okay, let's talk about how SRE handle keeping our systems consistent. Think of configuration management as a way to automatically set up and maintain our servers, ensuring everyone gets the exact same environment. We have a few popular tools for this, like Ansible, Chef, and Puppet. Ansible is great because it's easy to pick up and good at coordinating things across different machines. Chef uses Ruby to define what we want our systems to look like, which is really powerful if you need fine-grained control. And Puppet is fantastic when dealing with large environments. It's incredibly reliable and provides lots of reporting capabilities. Ultimately, the best choice depends on your team's experience and what works best for your specific setup. Okay, let's talk about how CI/CD really helps us become better SRE. Basically, we want to catch problems as early as possible, and that's where these practices come in. Continuous integration means we're constantly building and testing our code, often multiple times a day. It gives us immediate feedback on where the changes are causing issues. Then, continuous delivery takes that validated code and automates the process of releasing it to different environments. Think staging first, then production. But the really important thing is having those feedback loops in place. If something breaks, we find out quickly. And finally, integrating monitoring into our CI/CD pipeline, setting up alerts so we're notified immediately if anything goes wrong. That's absolutely key to reliability. Okay, let's talk about how SRE use automation. We're focusing on CI/CD tools today. Jenkins is a really established player. It's been around for ages and is fantastic for handling complex workflows. GitLab CI is super convenient if you're already using GitLab because the CI/CD is built right in. Argo CD takes GitOps to the next level, ensuring that your deployments always match what's in your code repository. And Tecton? It's a newer framework that provides a really flexible way to build powerful and scalable pipelines, especially useful for modern cloud-native apps. Let's talk about deploying software reliably. As an SRE, you're focused on keeping things running smoothly. There are different strategies to deploy new versions of applications, and today we'll dive into a few key ones. First up, blue-green deployments. This involves having two identical environments, one live and one ready for testing. We deploy the changes to the green environment, test them thoroughly, then switch traffic over. Rolling deployments are another approach. They gradually replace the old version with the new one in small increments, letting you catch problems early on. Canary deployments expose a portion of your users to the update, allowing you to monitor for issues before rolling it out completely. And finally, we can combine these strategies using rolling blue-green deployments. This gives us the best of both worlds, rapid rollback capabilities while maintaining high availability. Okay, let's talk about how GitOps can really level up our SRE practices. Basically, GitOps is all about treating your infrastructure as co-storing everything in version control like Git. Instead of manually configuring servers and deployments, we define the desired state of our systems and code, push those changes through a pull request process, and then automated tools like Argo CD or Flux CD take over to actually apply those changes. This gives us a full audit trail, makes rollbacks super easy if something goes wrong, and ensures everything is consistent across all environments. Okay, let's talk about keeping our infrastructure and applications safe. As SREs, security needs to be a core part of how we operate, not an afterthought. We'll start with the basics, making sure only people who need access have it, by using strong identity management. Then, we'll look at scanning for vulnerabilities and segmenting our networks to contain any problems if they do occur. Next up is application security, integrating security checks throughout development. And crucially, never, ever store secrets directly in your code or configuration files. Use a dedicated secrets manager. Finally, constantly monitor your systems for anything unusual and set up alerts so you can react quickly. Okay, let's talk about secrets. They are absolutely vital for any reliable system. As an SRE, you're constantly dealing with sensitive information, so managing it securely is a top priority. We don't just want to store secrets. We need to rotate them regularly, prevent unauthorized access, and ensure they stay encrypted at rest. There are several tools that can help sealed secrets, which works really well within Kubernetes. HashiCorp Vault provides a centralized hub with lots of powerful features like auditing, and AWS Secrets Manager is a solid choice if you're already heavily invested in the Amazon ecosystem. Think of it as building layers of security around your secrets. Okay, let's talk about identity and access management, or IAM for our SRE. Think of it as a critical layer of defense. It's all about making sure the right people have access to the right systems, and nothing more. We need to verify who someone is trying to log in as, using things like passwords or multi-factor authentication. Then, we need to make sure they're only allowed to do what they absolutely need to, that's authorization. And a really important principle is least privilege. Give people just enough access to do their job without giving them more than they require. Tools like your cloud provider's IAM service accounts for applications, and role-based access control are key elements of a solid IAM strategy. Okay, let's talk about immutable infrastructure, a really crucial concept for SRE. Basically, instead of tweaking our existing servers, we build entirely new ones whenever we need to make changes. It's like using Lego bricks. You don't alter the original pieces, you use them to construct something totally different. This approach helps us reduce errors significantly, because if something goes wrong, reverting to a previous known good state is much simpler than trying to figure out what was broken in a constantly shifting environment. We automate this process with tools like Terraform or Ansible, ensuring consistency and predictability, which are key for reliable systems. Okay, let's talk about Docker. Containerization is a really important concept for SRE. Basically, it's like packaging an entire application and everything it needs, its code, libraries, tools, into a self-contained unit called a container. Docker is the most popular tool for doing this. It creates images, which are like blueprints, and then turns those blueprints into actual running containers. Using Docker helps ensure your app runs consistently no matter where you deploy it, whether it's on your laptop, in a testing environment, or finally out in production. And because containers are isolated, they are also more secure and efficient than older methods of deploying applications. Okay, let's talk about Kubernetes. It's a massive part of being an SRE. Think of it as the conductor of your container orchestra. Kubernetes is this powerful platform that takes care of deploying and managing all those containers for you. At its core, a pod is like a tiny apartment building for your applications. It holds one or more containers working together. Nodes are the machines, the servers where these pods actually run. Deployments tell Keats how many copies replicas of your application you want running, and they handle updates smoothly so you don't lose service. And finally, services act as a consistent address for your applications, even if containers get moved around or replaced. Basically, Kubernetes takes the headache out of scaling, maintaining, and updating your apps. Okay, let's talk about observability. As an SRE, you need to deeply understand your systems, not just react to alerts. Observability is all about gaining that insight. It's essentially moving beyond traditional monitoring, which relies on predefined metrics. Instead of asking, is the CPU high, we want to know why it's high. Was it a sudden spike or something ongoing? Observability breaks down into three key pillars: metrics, as numbers like CPU usage and latency; logs, detailed records of what's happening inside your services; and traces. These are like breadcrumbs that follow a request as it moves through your distributed system. Combining all three gives you the best picture of what's going on, allowing you to troubleshoot problems effectively. Okay, so monitoring is a huge part of an SRE job. It's all about preventing problems before they become major headaches. We're focusing on two key tools, Grafana and Kibana. Grafana really shines when you need to see things happening right now, like CPU usage or latency, and set up alerts if something goes off the rails. Kibana, on the other hand, is fantastic for digging into your logs and finding patterns that might explain why an alert triggered in the first place. Often SRE use both tools together to get a really complete picture of what's going on with their systems. Okay, let's talk about log management and indexing, a really important part of being an SRE. Think of your system as constantly writing down everything it does in logs. We need to collect all those logs from everywhere and put them somewhere sensible. We don't just want a giant pile of text. We want to be able to actually find things within that data. So, we use tools like Fluent or Logstash to gather all the logs into one place. Then we process them, turning them into something structured like JSON and adding useful details like timestamps and service names. Finally, we index those logs so we can quickly search for specific events, errors, or anything that's causing problems. This ability to rapidly find information is a huge time saver when dealing with incidents. Okay, let's talk about finding out why your systems aren't performing as well as they should. When you're seeing slowdowns, it's not always obvious what's causing them. We often encounter bottlenecks like high CPU usage, meaning the computer is working really hard to handle requests, so maybe there isn't enough memory available. Disk access can also become a bottleneck, and of course, network latency can definitely slow things down. To help us figure this out, we use tools like profilers that show us exactly where time is being spent in our code, monitoring dashboards so we can spot trends, analyzing logs to find patterns, and even running load tests to simulate real-world user traffic. Okay, let's talk about how distributed systems fit into the world of site reliability engineering. Think of it like this: a lot of modern apps are built using smaller, independent pieces called microservices. They're kind of like Lego bricks that work together to build something bigger. These services need to talk to each other, and often they do that through message queues, which is like sending little notes between them. You'll also see databases split up across multiple servers for performance and reliability, and service meshes help manage all the traffic and security between these different parts. As an SRE, you're responsible for ensuring all of this works smoothly, monitoring everything, automatically fixing problems when they occur, and preventing those issues from happening in the first place. It's about building systems that are not only fast, but also incredibly resilient. Okay, so let's talk about how SRE makes sure all the parts of a distributed system agree on what's happening. That's where consensus algorithms come in. Basically, it's like making sure everyone is on the same page even if some computers are broken or acting up. Paxos and Raft are two really important algorithms that help with this. Paxos is a foundational algorithm, but it can be tricky to understand. Raft was designed to be much easier to grasp and implement while still providing strong guarantees. We also have BFT algorithms, which are especially good at dealing with situations where some of the computers might even be intentionally trying to trick the system. Think of it like this: you want a reliable system, and consensus algorithms give you that reliability by ensuring everyone's in agreement. Okay, let's talk about keeping our data safe, specifically how it gets replicated and stays consistent. Think of it like this: we need to ensure everyone sees the same, up-to-date information across all our systems. There are different ways to do that. We can use synchronous replication, where every write is immediately copied everywhere, which gives you strong consistency, but might slow things down a bit. Alternatively, asynchronous replication means we write to one spot and then copy it over later. That's faster, but there's a small chance of data loss if something goes wrong. Hybrid approaches like semi-synchronous offer a balance. And finally, consistency models define what happens when multiple users are reading the data at the same time. Strong consistency guarantees everyone sees the latest version, which is great for things like banking transactions. Eventual consistency is more common in social media. It's okay if you occasionally see slightly outdated information as long as everything eventually catches up. Ultimately, picking the right replication strategy and consistency model depends entirely on what your application needs to do. Okay, let's talk about a really important concept in distributed systems, the CAP theorem. Basically, when you're building systems that span multiple machines, you inevitably run into some tricky trade-offs. The CAP theorem boils down to this: you have to decide what's most important for your system. You can guarantee consistency, availability, or partition tolerance, but you can only pick two. If you prioritize consistency, you might sacrifice availability during a network outage. If you focus on availability, you'll likely accept that there might be temporary data inconsistencies. Okay, let's talk about deploying microservices, a big part of an SRE job. It's not just about getting something out the door. It's about making sure it stays reliable and performs well. We look at different deployment strategies like blue, green, and canary releases to minimize downtime when we roll out updates. Then, monitoring is key. We want to define clear service level objectives, basically what's considered acceptable performance. Error budgets help us manage risk, and we track things like latency and throughput to catch any problems early. Okay, let's talk about the basics of networking. It's super important for SRE. First up is DNS, which basically translates website names into numbers computers understand. Then we have HTTP, the language used to request and get web pages. TCP/IP is the underlying set of rules that makes all this communication possible. And finally, load balancing ensures your services don't crash when they get really busy. It's like spreading out the work so everyone gets a fair shot. Let's talk about how CDN fit into the bigger picture of SRE. Think of them as a network of mini servers spread out around the globe. They store copies of your website's files like images and code right near where your users are located, which means they can access those files much faster. This dramatically improves website speed and reduces latency. CDN rely on edge servers, which are individual servers that handle requests from local areas. And a key part of managing a CDN is deciding how often to update the cached content. That's where caching strategies like TTL come in. As an SRE, you'll be responsible for monitoring these networks, tackling any issues with caching, and making sure everything is routing correctly. Okay, let's talk about release engineering. It's a really important part of being an SRE. Basically, we're not just handing off code to the operations team, we're building systems and processes to make sure deployments are predictable and reliable. First, you need to plan deciding how often you'll deploy, what environments you'll use, and most importantly, having a solid rollback strategy if something goes south. Then comes automation. Tools like Terraform or Ansible help us set up and deploy infrastructure consistently. CI/CD pipelines are key to automating the build, test, and deployment process. Drastically reduces manual errors. Don't forget monitoring and alerting. We need to know immediately if anything's amiss after a release. Finally, always validate your deployments with automated tests just to be extra sure everything is working as it should. Okay, let's dive into canary. Release is a really important SRE technique. Basically, we deploy a new version of our application to only a small group of users initially. This helps us catch problems before they impact everyone. It's like a test run. We keep a close eye on things, how the app is performing, how users are reacting, and have automated rollbacks in place just in case something goes wrong. If we see any issues that push error rates or slow things down too much, we automatically switch back to the reliable version. Then, as everything looks good, we gradually expose it to more and more users. Okay, let's talk about how automation plays a critical role in the life of an SRE. Basically, SREs spend a lot of time on repetitive tasks, things like restarting services or checking system health. To make their lives easier and ensure consistent operations, they rely heavily on scripting. We'll look at 3 languages that are particularly popular: Bash, Python, and Go. Bash is great for quick fixes and basic system administration. It's perfect for getting something done fast. Python is incredibly versatile. You can use it to automate complex processes, build powerful automation frameworks like Ansible, and even do a lot of data processing. And finally, Go, or Golang, is known for its speed and efficiency, making it ideal for building high-performance systems and tools used in cloud infrastructure. Let's talk about preparing for the worst. As SREs, we need to go beyond just fixing things when they break. This slide outlines how to plan effective incident drills and simulations. First, you need to identify which of your services are most critical, those that would cause the biggest impact if they went down. Then think about realistic scenarios, like a database outage or network problems. Create detailed playbooks outlining exactly what steps to take when different situations arise. Don't forget to assign roles so everyone knows their responsibilities and use the right tools for the job. Finally, remember that these plans aren't set in stone. You should regularly review and update them based on what you learn during your drills. Alright team, let's talk about metrics. As SREs, we need to be constantly monitoring our services and understanding how well they're performing. We focus on a few key areas: availability, which is basically uptime, and TTD, measuring how quickly we spot problems, and TTR, the time it takes to actually fix them, error rates, indicating how often things go wrong, and latency, how fast our systems respond. It's important to remember that collecting data is only half the battle. We need to analyze those numbers to identify trends, potential issues, and areas for improvement. Let's keep a sharp eye on these metrics. Okay, let's talk about creating a really healthy environment for SRE, one where we can learn from failures instead of dwelling on them. We're focusing on postmortem culture and blameless retrospectives. A postmortem isn't about finding someone to blame, it's actually a deep dive into what exactly went wrong, why it happened, and most importantly, how we can prevent similar issues in the future. Think of it as an investigation focused on the system itself. Then we introduce blameless retrospectives. These are structured sessions where we shift our attention away from who's at fault to what can we do better. We use techniques like asking why repeatedly, and diagrams like fishbone diagrams or Ishikawa diagrams to really get to the root causes of problems. The key is that we keep the focus on systems, not people. We want a detailed record of what happened, and then we translate those observations into actionable steps, things we can actually do to make improvements. Okay, let's talk about a really important challenge SRE face: the availability versus consistency trade-off. We always want our services to be up and running, right? That's huge for user experience. But when we push really hard for 100% uptime, especially in complex distributed systems, it can sometimes mean sacrificing immediate data consistency. It's like making a choice. Do you want things to happen instantly, or are you okay with a slight delay, but knowing that everything will eventually catch up? For example, imagine seeing a social media post appear immediately for some people, and then a few seconds later for others. That's often due to these trade-offs at play. Okay, let's talk about keeping our services running smoothly. Achieving zero downtime during deployments is a big deal for SRE. We want a seamless experience for our users, and that starts with reliable updates. There are several techniques we use. One popular approach is blue/green deployment, basically having two identical environments, one live and one staging. When the new version is ready, we simply switch traffic over. Another method is canary deployments, where we release a feature to just a small portion of our users initially, allowing us to catch any problems early on. Rolling updates are another way to slowly replace older versions with newer ones, and then there are feature flags which let us control exactly when features are available without even deploying new code. The best strategy depends on your application's needs. Okay, let's talk about keeping our databases running smoothly and reliably. Database high availability is a top priority for SRE. We achieve this primarily through replication, basically copying data to other servers. With MySQL and MariaDB, we typically set up a master-slave configuration where the main server handles all writes, and changes are then copied to one or more backup servers called slaves. These slaves can take over if the primary fails, but there's sometimes a slight delay due to asynchronous replication. Now, PostgreSQL offers streaming replication, which is a really cool technology that copies data blocks directly between servers in real time, resulting in lower latency and better consistency compared to traditional log-based methods. It also allows for cascading failovers across multiple nodes, making our system even more resilient. Alright team, let's talk about backups and restore. Super important for any SRE. Basically, we want to be prepared if things go sideways. We'll start by discussing key strategies, regular full backups, making complete copies of everything on a schedule, like daily or weekly. Then there are incremental and differential backups, which only capture the changes since the last backup, saving time and space. Snapshotting is also great for quickly reverting to previous states. It's important to think about our recovery time objective. How long can we afford to be down? And our recovery point objective, or RPO, which is how much data loss we're willing to accept. These objectives drive the whole backup strategy. Let's make sure they align. Okay, let's talk about API gateways. They're seriously important for any modern application. Think of them as the front door to your services. They handle lot of stuff, controlling how much traffic comes in, making sure everything is secure, and then directing that traffic to the right back-end systems. We'll cover things like rate limiting to prevent overload, security measures to protect against threats, and even transforming requests so different parts of your application can talk to each other seamlessly. Now, when it comes to high availability, SRE need to ensure these gateways are super reliable. That means deploying them across multiple zones so if one zone goes down, another can pick up the slack. Load balancing distributes traffic evenly, and constant monitoring with alerts helps catch problems before they impact users. Basically, SRE are responsible for keeping those gateways running smoothly and reliably. Okay, let's talk about keeping our systems running smoothly. Today we're focusing on how SRE handle failures gracefully. We'll start with the circuit breaker pattern. Think of it like a safety switch that prevents one failing service from bringing down everything else. It monitors its dependencies, and if things keep going wrong, it temporarily stops sending requests. Then we'll dive into retry strategies. Simply trying again after a failure can often work, but it needs to be done intelligently with techniques like exponential back, gradually increasing the wait time between retries and adding some jitter to avoid overwhelming the service. Combining these two approaches gives us really solid resilience. Okay, let's talk about how to protect your services from getting overwhelmed. Today we're focusing on rate limiting and throttling. They are both important tools for an SRE. Rate limiting is a straightforward approach. It sets a hard limit on how many requests a user or client can make within a certain period, like 100 requests per minute. Throttling, on the other hand, is more flexible. It gradually slows down the rate of incoming requests as needed, based on things like usage patterns. Think of it like gently easing up on the gas pedal instead of slamming on the brakes. Both techniques are vital for preventing abuse, safeguarding against attacks, and ensuring everyone gets a fair shot at using your service. Let's talk about service meshes. They are becoming increasingly important for managing complex microservice architectures. Essentially, a service mesh is like an invisible layer of infrastructure that handles all the messy details behind the scenes, things like routing traffic, monitoring performance, and securing communication between your services. We have some big plays in this space: Istio, which is powerful but can be a bit complicated to set up; Linkerd, which is known for being lighter weight and easier to manage, perfect for smaller teams; and Console Connect, which seamlessly integrates with HashiCorp Console, making it a great option if you're already using that platform. At their core, service meshes use proxies, often called sidecars, that sit alongside each of your services and intercept all the network traffic, allowing them to enforce rules and collect valuable data without needing any code changes in your applications. Okay, let's talk about health checks. They are a fundamental tool for any SRE. We have two main types: liveness and readiness probes. Liveness probes basically ask, is the service still running? If it fails, it means something is seriously wrong, and we need to restart the container. Think of it like checking if your computer's on. Readiness probes go a step further. They check if the service is *ready* to accept requests. They ensure things like database connections are up and running and that all necessary data is available. So liveness says it's alive, while readiness says it's ready to serve. Combining both gives you a really solid way to monitor your systems and react quickly to problems. Okay, let's talk about configuration drift, a really important concept for any site reliability engineer. Essentially, it's when your systems slowly start to stray from their intended state. Think of it like a ship gently drifting off course. It sounds small at first, but over time, that little drift can lead to some big problems. We want to catch this early because configuration drift causes unpredictable behavior, more errors, and ultimately downtime. So how do we detect it? Well, automated monitoring tools are crucial. Things like Prometheus and Grafana constantly track key configurations and alert us when they change unexpectedly. You can also integrate your monitoring with version control systems, so a config change automatically triggers an alarm. And finally, regular audits of your configuration management tools, such as Chef or Puppet, ensure you're comparing the actual state to what's documented. It's all about proactively preventing those little deviations from becoming major issues, just like Google's SRE team suggests. Okay, let's talk about how SRE handles security incidents. Think of it like a well-defined playbook. First, we need to detect something suspicious. Our monitoring tools are constantly on the lookout. Then, we quickly contain the problem, usually by isolating affected systems. Next comes eradication which means actually fixing the root cause, often patching vulnerabilities or removing malware. After that, we recover the service and make sure everything is working correctly again. Finally, we do a thorough post-incident analysis (PETA) to learn from what happened and improve our defenses for the future. Tracking metrics like MTTD and MTTR helps us see how well we're responding. Okay, let's dive into how we manage risk as an SRE using something called an error budget. Think of it like a safety net for your services. We start by setting clear goals. What level of uptime do we want? Then, based on those goals, we calculate a specific amount of downtime that's acceptable over a certain period. It's essentially a limit on how many mistakes we can make before things go wrong. We track our errors against this budget, and when it runs out, it's time to figure out why and fix the root cause. It's all about proactively preventing problems and making sure our systems are reliable. Okay, let's talk about how we build testing into our site reliability engineering processes. It's not enough to just react when something goes wrong, we need to be proactive. We do this by moving testing left, meaning incorporating it earlier in the development process, starting with unit tests and working our way up. Then, we use chaos engineering, essentially controlled experiments where we deliberately introduce failures into our systems to see how they respond, really honing our resilience. And of course, automated regression tests are vital to ensure that new code doesn't break what's already working. Finally, performance testing helps us keep an eye on things like response times and scalability as the system grows. All this data feeds directly into our SRE pipelines, letting us know if something needs attention. Okay, let's talk about managing our test environments. As an SRE, getting your tests running reliably in a realistic environment is absolutely key. We need to make sure those test beds closely mimic production. That means automating everything we can with tools like Terraform or Ansible for infrastructure provisioning. Configuration management is just as important. Keeping the configurations consistent across all environments helps avoid unexpected behavior. And of course, protecting sensitive data is paramount, so masking and isolating production data in our tests is a must-do. Don't forget monitoring. Keep a close eye on performance and resource usage to spot problems early. Finally, regular refreshes and cleanup help ensure the test environments stay up to date and ready for the next round of testing. Okay, so let's talk about how we use distributed caching as SRE. It's a critical part of keeping applications running smoothly. Basically, caching is all about storing frequently accessed data in memory to speed things up. But when you have lot of users, one server isn't enough, right? That's where a distributed cache comes in. It spreads the data across multiple servers so it can handle more requests. We'll look at two popular options, Redis and Memcached. Redis is like a super-powered key-value store with lots of different data types and even persistence, meaning it can save data to disk if needed. Memcached, on the other hand, is simpler and incredibly fast for basic caching. It's great for things like storing images or user sessions. As SREs, we constantly monitor how well the cache is working, checking hit rates, how often we find what we're looking for, and making sure it's not running out of space. We also shard the cache across multiple servers to handle increased traffic. Okay, let's talk about cloud cost optimization from an SRE point of view. A lot of times, teams get really excited about building new features and don't always think about the cost side of things that can lead to a huge spike in cloud bills. We need to focus on making sure our infrastructure is efficient. It's all about understanding where the money's going, right-sizing our instances so they aren't over-provisioned, and then using tools like reserved instances or savings plans when we know we're going to be needing resources for a longer period. And don't forget about spot instances. Those can offer huge discounts if you have workloads that are resilient to interruptions. Basically, SRE are the guardians of cloud budgets. Okay, let's talk about managing things when you're dealing with multiple clouds, maybe even some on-premise stuff too. As an SRE, you'll be spending a lot of time keeping all those pieces working together smoothly. The key is to have a central place where you can see everything happening, like your monitoring tools. Then, automation is your best friend. Use things like Terraform or Ansible to make sure everything is set up the same way across all environments. Thinking about infrastructure as code, basically writing rules for how things should be really helps with consistency and reduces mistakes. And let's not forget cost. You'll need to constantly look at your spending and find ways to optimize resources. Okay, let's talk about automating those crucial runbooks and playbooks. They are a massive part of an SRE job. Basically, we're looking at ways to ditch the repetitive manual steps and replace them with automated processes. Runbooks are like detailed instructions for specific incidents. Think, how do I restart this service? Playbooks are more strategic. They outline the overall approach to a problem, often pulling in multiple runbook steps. We can use tools like infrastructure as code to make sure our environments are consistent. Scripting languages and workflow automation platforms like Jenkins help us actually automate those individual steps and trigger other actions based on what's happening during an incident. Okay, let's talk about keeping things on time in a world of servers spread across different places. When you have multiple computers working together as a system, getting everyone to agree on the same time is surprisingly important. It sounds simple, but without it, logging becomes a nightmare. Correlating events from various machines is nearly impossible. Debugging gets much harder too, and you could end up with data that's inconsistent or just plain wrong. We use things like NTP, which is really common for basic syncing, and then more advanced options like services for better accuracy, or even atomic clocks if we absolutely need pinpoint timing. Basically, accurate time keeps the whole system running smoothly. Okay, so let's talk about how compliance fits into the SRE role. It's more than just ticking boxes. It's about making sure our infrastructure is operating in a way that meets both internal rules and external regulations like GDPR or HIPAA if we're dealing with sensitive data. We need to understand those policies, track them, and build systems using things like infrastructure as code that help us maintain consistency and show where everything comes from. Then, monitoring security logs with SIEM tools is super important for spotting potential problems early on. Basically, compliance is a critical part of ensuring our systems are reliable and secure. Okay, let's talk about service discovery. Think about it. In a modern application, you often have lots of different services all talking to each other. But those services are constantly being updated and scaled. New instances come online, old ones go down. If your client code has hard-coded addresses for these services, then when something changes, you'll quickly run into problems. That's where service discovery comes in. It's basically a way to automatically find the current location of a service without needing to constantly update your configuration files. We have options like using DNS, which is pretty common and straightforward, or more advanced solutions like service meshes or centralized registries, each with their own strengths and weaknesses. The best choice really depends on how complex your system is. Okay, so let's talk about how site reliability engineers really connect with the bigger picture. It's not just about keeping servers running smoothly, it's about making sure that reliability actually matters for the business. We have service level indicators. Those are the technical metrics we track like uptime and response time, which tells us a lot about our systems. But business KPI, like revenue or customer satisfaction, are what we're ultimately trying to influence. When something goes wrong technically, it can directly impact these goals. So, as SREs, we need to understand how our technical work ties into these key business objectives and proactively monitor those connections. Okay, let's talk about scaling stateful applications. These are apps that need to remember things like databases or queues. The challenge is that as you get more users, managing all that persistent data gets really complex. The best practice: Try to design for statelessness whenever possible, so requests can go anywhere without needing to track previous interactions. If you asterisk to handle state, sharding your data across multiple servers is crucial. Think of it like splitting a giant table into smaller ones. We also need redundancy, replication and load balancing ensures things don't break if one server goes down. And for session data? Offload it to external services like Redis or Memcached. As an SRE, you'll be keeping an eye on all of this, spotting bottlenecks and using automation tools to keep everything running smoothly. Okay, let's talk about taking things a step further with Kubernetes. When the standard tools aren't quite cutting it, SRE often dive into creating their own custom controllers and operators. Think of these as powerful extensions that let you tailor Kubernetes to your specific needs, automating complex processes and managing workloads in super precise ways. We're talking about defining what new objects you want to manage within Kubernetes using ZRD and then building the logic or controller to keep those objects in the state you desire. Finally, these controllers are often packaged into operators which handle things like deployment, scaling, and updates automatically. It's a powerful way to really nail down your infrastructure management strategy. Okay, let's talk about how we make sense of all the data we collect in SRE. The most important thing is to define what success looks like, our service level objectives or SLO. We also need an error budget, which is essentially the amount of downtime we can tolerate before things start going wrong. Then, we track metrics like request volume and transaction rates. To really understand how things are running, we don't just look at individual data points, we aggregate them, meaning we group similar data together to spot trends. Tools like Prometheus and Grafana help us do this really effectively. And finally, it's crucial to choose the right way to visualize the data. A line chart can show you how latency is changing over time, while a heat map could quickly highlight where problems are occurring. Let's talk about how RPC systems fit into the SRE world. Essentially, RPC lets different parts of your application communicate with each other as if they were talking to a local function. We'll look at two common options, gRPC and Thrift. gRPC is generally considered more modern and faster thanks to using HTTP/2, while Thrift has been around longer and can be really effective when optimized correctly. Think of it like this: RPC helps us build robust, scalable services by allowing them to work together seamlessly. Okay, let's talk about how we scale our infrastructure as SRE. It's not just about throwing more servers at the problem. That's often a recipe for disaster. We need to think strategically and use established patterns. Horizontal scaling is all about adding more instances of your service. It's fantastic for handling increased traffic, but you have to deal with things like data consistency, which can get complicated. Then there's vertical scaling, basically just making existing servers bigger. It works, up to a point, but eventually you hit hardware limits and face downtime during upgrades. Database sharding is another approach that breaks up large databases into smaller pieces, improving performance, but also adding operational complexity. Caching plays a huge role too. Think of it as reducing the load on your main systems by storing frequently accessed data in faster places like CDN or memory caches. And finally, load balancing. Distributing traffic across multiple servers is absolutely essential for ensuring high availability and speed. Okay, let's talk about how we ensure our software is solid before it hits the real world. We've got these things called quality gates. They are automated checks built into our CI/CD pipelines. Think of them as checkpoints that make sure everything looks good and is ready to go. They basically stop us from deploying anything that isn't up to par. We might check for passing unit tests, ensuring the code covers a certain amount of functionality, or even verifying that the servers are prepared to handle the load. It's all about catching issues early, which makes things much smoother in the long run and significantly reduces those nasty production incidents. Okay, let's talk about resource management in Kubernetes. As an SRE, you need to understand how to control what your pods are allowed to use. Think of it like setting boundaries for each application. We have two key concepts, requests and limits. Requests tell Kubernetes the minimum amount of CPU or memory a pod needs to run properly. It guarantees that resource will be available when scheduling. Then there are limits which define the maximum usage. If a pod tries to go over its limit, Kubernetes will throttle it down. It's important to set these correctly. Too low and your applications won't perform well, too high and you risk impacting other pods in the cluster. Okay, let's talk about securing the edges of our applications and the API that power them. As an SRE, this isn't just a development team problem, it's your responsibility. Think of the edge as your first line of defense, constantly receiving requests from users worldwide. We need to protect it with tools like web application firewalls to filter out bad traffic before anything even reaches our applications. And API. They are prime targets for attackers. API gateways help us control access and validate data. Rate limiting helps prevent overload, while authentication ensures only authorized users can do things. DDoS protection is a must-have, too. Finally, don't forget about TLS. Ensuring strong encryption and monitoring for vulnerabilities are vital. And remember, automation integrating security checks into our pipelines, that's how we stay ahead of the curve. Okay, let's talk about remote logging, a super important area for site reliability engineers. The first thing is to have a centralized logging system like ELK or Splunk. This gives you one place to look at all your logs. Next up, structured logging. Instead of just plain text, format your logs as JSON with key pieces of info, making it way easier to search and analyze. We'll see an example here. Then, we need to think about how long we keep our logs. Log rotation and retention policies are critical for managing storage. Finally, make sure you're using secure transport like TLS when sending your logs around. Okay, let's talk about capacity alerts and how they tie into our work as SRE. Basically, we need to know when things are getting tight, like if a server is running out of CPU or memory. Capacity alerts are designed to give us that early warning signal. They are triggered when key metrics go above certain thresholds, maybe 80% CPU utilization for example. Then, auto-remediation comes in as the next step. It's where we automate responses to those alerts, things like adding more servers, restarting a service, or even rolling back a deployment, all without needing us to manually jump in and fix it. It's important to set our thresholds carefully to avoid false alarms, and of course, always test your automation scripts thoroughly before putting them into production. Tools like Prometheus, Grafana, and Kubernetes operators can really help with monitoring and automating these processes. Okay, so let's talk about proactively keeping things running smoothly. As an SRE, it's not enough to just fix problems when they happen, we need to see them coming. We do this through robust monitoring and predictive analytics. Think of your metrics dashboards. These are like constant visual updates on the health of your services, showing you key data points like CPU usage and response times. Automated alerting systems will flag anything unusual so you can investigate before it escalates. And don't forget about log aggregation. Having all your logs in one place makes troubleshooting a lot easier. But predictive analytics takes things to another level. By analyzing past trends, we can actually forecast potential failures and take action before they occur. It's all about staying ahead of the curve. Okay, so let's talk about how site reliability engineers fit into the world of DevSecOps. SRE aren't just about keeping systems running smoothly, they're actually playing a huge role in building security into our applications and infrastructure from the start. They automate a lot of the repetitive security tasks that would otherwise fall to developers or security teams, like scanning for vulnerabilities and fixing them automatically. Plus, SRE are deeply involved in monitoring systems for any potential threats, working hand in hand with security folks during incidents to quickly get things back on track while minimizing risk. They also use their operational knowledge to anticipate capacity needs related to security, helping us stay ahead of the game and proactively address problems before they become major issues. Think of it like this: SRE are taking a really data-driven, proactive approach to security, moving beyond just reacting to problems to actually preventing them in the first place. Okay, let's talk about keeping our services running smoothly. A key part of an SRE job is managing deployments, and sometimes we need to slow things down. That's where deployment freezes come in, essentially, a temporary pause on new releases to give us time for extra checks. Alongside that, we have a change management process, which is basically a roadmap for proposing, designing, testing, and deploying changes safely. It includes clear planning, thorough code reviews, and a detailed rollback plan should anything go wrong. Okay, let's talk about continuous delivery of infrastructure. As an SRE, you're all about making sure things run smoothly and reliably, and it starts with how we deploy everything, not just our applications. Basically, it means automating the entire process from code changes to putting them live in production. We want small, frequent updates instead of huge, risky releases. Infrastructure as code is a really important part of this. We define all our servers, databases, and networks using code, so they're consistent every time. And testing, we need to test changes in real-world environments before rolling them out completely. Things like canary deployments or blue/green approaches help us do that safely. Okay, let's talk about disaster recovery testing. It's absolutely crucial for any reliable system. As an SRE, you're not just documenting a plan, you're actively verifying that the plan actually works. We do this through several different types of tests, starting with tabletop exercises where we walk through scenarios with the team, then moving to partial failover tests to check specific parts, and finally simulating complete outages, often in our staging environments. Tools like chaos engineering platforms help us inject controlled failures to see how our systems react. It's all about monitoring key metrics during these simulations and using postmortems to continuously improve our recovery procedures. Don't just have a plan, prove it. Thank you for watching.